Hello, everyone. Welcome to my talk here at the Data Streaming Summit 2025. And thank you so much to the organizers for having me here. I'm very happy to be here and to talk about event-driven and multi-agentic architectures for complex workflows in generative AI systems. And then I'll introduce to Gen AI a bit of introduction, especially since maybe not everybody has worked with Gen AI, so bear with me, just a little bit of introduction. And then I'll talk about agentic architecture. And then I'll also talk about event-driven world and AI, and then applying event approach to retrieval augmented generation, RAG, and also applying event-driven approach to agents and workflows. And I'll also discuss some challenges of Gen AI and then share with you some resources. First of all, who is Mary? So I am the Director of Emerging Technologies at Calibrity. Calibrity is a consulting firm in Cincinnati, based in Cincinnati, Ohio, and I myself, I'm based in Chicago. And before this, I was a developer advocate for 6 years or so, like between IBM and then at DataStax, and into generative AI and agentic architecture. So when I talk about AI, basically, too, on the left side, I wanted to share kind of two fundamental diagrams. The left side is simpler, it's more higher level, it's about AI. It's actually really what it is mimicking the intelligence or behavior pattern of human or any other living entity. That's an all-encompassing term, and it's so prevalent these days. It's actually it existed, back in even in the 60s. Not even so. It's actually the last century, like 100 years. It's been all the developments kind of towards what it is today, and that's AI. It's more abstract, higher level. And then if you kind of drill down inside, then there's machine learning, and that's the layer that's actually talk more about the techniques by which a computer can learn from data without us explicitly training it, right? So basically, we're giving it data, complex set of different, using complex rules, and basically train the model on data. And this approach is mainly based on training the model from data sets too. And as such, there are essentially like three primary way of training. One is supervised training, and then unsupervised training, as well as reinforcement learning. Now, the thing is, though, with just machine learning itself is not able to solve all the problems. And the really difficult ones are basically in the core set of inside this. If you look at it, the inside, the innermost, which is the deep learning layer. It involves the technique to perform machine learning that's inspired by how our brain's neural system works, right? It's how the complex network of neurons and our nervous system works too. And that's what it's the deep learning is to mimic that part. Now, going over to another person. So, and let me, actually, I also forgot to, is one thing I wanted to emphasize is the data part. So without data, there wouldn't be any AI or machine learning at all. So data is very, very crucial to making things happen in here. And so I wanted to also kind of point out to the large language models. So these are in the Gen AI era. It's basically, these are generative models. It's basically what it does is it generates something, right? So initially, to all of the models that came out, OpenAI, everybody is aware of. That's the de facto, that's what ChatGPT came out of, GPT 3.5 that appeared in November of 2022. And then very soon GPT 4.0, and now also the GPT 4.0 mini, O1 and O1 mini. All of these are like multimodal systems too that are quite sophisticated, and it's moving towards artificial general intelligence, AGI. That's kind of deals with the reasoning part. Now, just bear in mind too, all of this reasoning, despite the fact that there are people saying that okay, AGI is here, but the fact is to really have machines able to reason things, then that part is actually going to be very difficult. Even though there are some advances, but it's nowhere near how human beings can, the way how humans think too, like the emotions and feelings, all of these things. So just want to point it out. As you can see too, like I won't kind of step into all of it, DeepSeek is also one of the more recent models that came out. It's more efficient than OpenAI are supposed to be. And of course, too, when we talk about models too, is that there are also different modes that it support, right? There can be text, image, video, or three-dimensional code, as well as audio too. So all of these two, like visual, video as well. So all of these two, they're intermodal now, meaning we can do text to image, image to video, for example. All of these are really kind of big advances too. And as you can see, these are like the more popular models here that I've listed in here. But I won't go into all the details. I just want to point them out too. Some of them, for example, Stable Diffusion is the first, essentially the diffusion, very successful text-to-image diffusion model. And then comes after is Dolly and Midjourney, all of these things. So as such, I just wanted to point out the generative model. So with this LLM, right, we all know too is that it's not LLM, despite the fact that, yes, it is kind of a big, advance. But the thing is, we have to understand too, there are limitations to it too. Essentially, too, it's garbage in, garbage out. So what the language model is capable of doing is basically based on the data set that is being trained on. Essentially, too, LLM itself doesn't have any memory. And also, not only that, and one big problem is that it's using fuzzy logic. It's non-deterministic too. And also, to the answers, you can't really add attributions to the answers. Not only that, the cost is also very high. It's not cheap, as we all know. And in fact, there are also research that shows that or experiment being done that in which you want to do the same kind of searches, for example, and you do it in regular search, and if you compare with using an LLM to do pattern matching, essentially that would be more expensive in the Gen AI side of things. But although the chip makers are making it cheaper and cheaper every day. But so that's the issue with that. It is a one-shot deal, right? You ask questions, and these days all of these interfaces are kind of built-in chain of thought, so you can kind of build a context around a set of questions you are asking, right? But then if you kind of just work with the LLM just like that, it just cannot remember. You ask it one time and it comes back, you go back and ask it another time, it cannot simply remember what you have asked before. So those are the kind of things we need to be aware of. And not only that, it really is not ready for enterprise level types of applications in which we are looking for scalability, looking for persistence, complex tasks and workflows. And again, doesn't have memory, so it doesn't manage the state of data as well. So in order to be able to do that, right, what can we do? So that's when these days is basically, I believe it's kind of, if I recall back, maybe roughly, about 9 months ago when agents, this whole talk of agents can't come out now. We're talking about agentic architecture. So basically, it is a structure and design of a system of AI systems that leverages on AI agents to perform the tasks. What kind of tasks, right? So it's essentially autonomous execution. Now, don't forget too, these are supposed to be artificial intelligence. So perhaps there's no need to be coding so much to actually do some of these difficult things, right? So we need to maybe have the bot to sort through all the data and everything. So the autonomous execution part, basically agentic architecture should be able to handle that part. Tool integration, seamless scalability too. We're supposed to be able to do it. So can we leverage, right, agents that are running in serverless architecture in a cloud native type of systems and leverage on their scalability that's built into cloud native systems, as well as like resiliency, recoverability. Notice that all of these specific kind of goals that we're trying to achieve is essentially what distributed systems are doing, right? It's trying to do all of these things that event-driven systems, or once used to be, we call it more reactive systems, that kind of manifesto, same kind of thing. But now we're basically leveraging on large language models to handle some of these complex tasks too. Now, the thing is too, let's take a look at agentic architecture, some key concepts about it. we're talking about, vertical architecture in which you can have one agent leading, so to speak, right? So one agent is kind of the primary one that's more vertical, and everybody else is kind of leaning on this single or kind of like a leader agent to kind of decide on how to do things, for example. Now, there's also horizontal architecture in which you can have multiple agents that are collaborating. Each agent is specializing in some specific task, and they need to all accomplish a bigger task together. Now, the thing is too is that we're also talking about agentic orchestration too, much like a computer, or actually much like an orchestra, right? And then we in an orchestra we often see a symphony orchestra. There's a conductor conducting the music, so then the music will come out to be pleasant to the ear. Likewise, if we're doing agentic type of task kind of workflow, we want many agents doing things, but we need somebody in there being the overseer, the leader, to kind of orchestrate, making sure all of the agents are performing things, and maybe there are things happening with this agent, their data being received on the other end. All of these things too is this orchestration piece of it. And also too, essentially, is helping with very complex task execution and dealing with also decision making can be autonomous now. There's no need perhaps for us to write some kind of decision process. It's essentially letting the agent help with this, making it autonomous for us. And the reasoning part, planning part, and a continuous learning stuff too. Maybe the agents itself too, every time is asking the LLM, is trying to learn it too through the LLM. Now, let's take a look then at the event-driven world and AI. So this is a data streaming summit. I'm assuming everybody is already must be enthusiasts or experts in working with data. And as such too, in an AI world, at the heart of AI is basically data. And also not only that, it's the flow of the data in many directions. So when we work with data, let's take a look, right? We're dealing with architecture level. It's an enterprise driven type of an enterprise level architecture that can be event driven. And then within it too, we have to handle the data. Data itself isn't just static, much like air, right? We have air that can basically in gas, or gaseous format, water format, or like ice, kind of solid. But in this case, data has the rest in a restful state in which data will be residing inside, for example, a storage type of capability, which is like inside a database, inside a file system, or whatever it is at rest. And then it can be in transit as well, is when data is traveling from one node to another, source to destination, for example, that's in transit. And also data can be in use is when let's say we're working with data, we extract them from a database, and then we're operating on it and manipulating, updating the data before writing it back to disk, something like that. And then there are also techniques too, and that's what this summit is really all about, is the streaming part, event streaming. Essentially is dealing with data that's happening all asynchronously. It's all driven by events. When events happen, it carries with it data itself, and it can be like many processes, many events that are happening too. And then there are also the messaging aspect, in which we're now talking about the more like on the level of messaging. How do you have some data as carried by some events, being sent, the data being sent from A to B, like that. For example, using a PubSub type of broker kind of approach, or using a message queue. If their messages deposit inside a queue, and it would be picked up by the clients, all of these things. And of course, there are also techniques such as event sourcing, in which we're now not only are we storing the status of the data inside a table, but we're actually tracking the state changes of the data as it happens too. So it helps with a lot of playback type of scenario. And then there are also CQRS. It's the pattern of dealing with command, query, responsibility, segregation. You separate the read and the write to make it very efficient too. Now, let's take a look then at generative AI streaming usages. Basically, too, I look at it like Gen AI is just like any other kind of system in which we have input in the forms of prompts. Prompts can be sent, from a command line or from a web browser on different types of devices, or like desktop application or mobile app too. Then that would be requests that are coming in just like any events. You press the send button, that that has generate like a request that goes out to for further processing. And then there are also Gen AI then intermediary steps such as doing a RAG operation, retrieval augmented generation, which I'll talk about it a little bit in the next section. It's basically too with RAG operations is that there is this retrieval side in which it is retrieving data right from external sources such as a database, file system, could be from a web, any kind of like kind of communication socket, right? Message queue, a Kafka topic, such as that. And basically, too, that the RAG takes the input and basically it will eventually wrap up your new prompt and then have that be sent to an LLM. And then, of course, too, then from the, I'm simplifying here, but the thing is, too, the large language models will come back to with the responses, right? It's doing pattern matching or so to speak, like searches too. And it response was sent back, and you need to stream it back, maybe, in some scenario. Now, let's talk quickly too about benefits of the event-driven approach. I'm really like kind of a supporter of this kind of approach because it handles the dynamic nature of data and its flow patterns, and it can help with communication asynchronously via event streams, and it enables scalability and flexibility. So because all of these components are loosely coupled, your client and server, they are all separated. So that helps with the scalability aspect much easier too than if you have to tightly couple any kind of components. And it facilitates too, not only that in an, let's say, in an event-driven world, we can actually have agents that are being done leveraging on event-driven approach, and basically too each agent can be talking interacting with certain LLMs as well, because they're as such they are LLMs that are better at doing that's their goal is doing code, code generation. For example, Codex is kind of the model for code generation, right? Programming code. And there are also, like, for example, Sora is for video from OpenAI. So you can have agents that are doing different things and interacting with different LLMs as well. But aware too of the challenges with these kind of systems, right? That they are more difficult to debug and also harder to track the flow of calls and the data that they carry, especially in like a pub/sub type of scenario. We all know some events and happening. The broker, it comes, and the broker will handle it, and basically it's published on is basically on a listener. So then whoever is listening on it or subscribe to this endpoint or a topic, right? Then basically too, we have to make sure we have built-in observability support for it in order to track all of the flow and the data that they carry. And most important of all too, we all know too there are cases in which things don't work as expected. So in that case, you have to be able to do debugging, to do tracking and replay of data, all of these things too. Now, let's take a quick look. Gen AI with RAG, retrieval augmented generation, is being talked about all the time. And just now I talk about how retrieval model and generative model, the retrieval side is basically responsible for, it's like a specialized librarian, because it is going to pull in relevant information from a database or a corpus of documents too. Then the information is then fed to the generative model side, which acts as a writer. So it kind of crafts up all of these coherent and informative text based on the retrieved data too. So these two models work in tandem and then provide answers that are not only accurate, but also contextually rich too. Now then, the generative model side as such, is responsible for generating the responses. For example, I asked it to write a blog article for me, and it's basically doing all the embellishment to it, to making your answers in text form even more enriching too. And it can also be generating images, generating videos, all of these that are also like in this RAG pattern as well. So as we can see, we can also be leveraging on event-driven approach to do RAGs as well. Now, let's take a look at agents and workflows. So agents, let me repeat again, it's basically agents if it's not within computing context, and think of, it is actually very kind of natural in how, human beings interact too. We live in a complex world. We don't sit around, right? So, and the thing is too, sometimes we just cannot be specializing in everything, and that's when we're going to need agents that are specialized in certain things that can help us. For example, in real life, we need travel agent to help us make travel reservations and payment, all of these things. And or we can have, we have car insurance, house insurance. We need an agent to help us to write all of the underwriting, all of the rules, all of these things. So likewise, in a generative AI scenario, we need an agent to be acting on our behalf and do things, specializes in everything. And in this particular case, in an AI scenario, agents are also could be interacting with LLMs in a lot of cases as well. So agentic too essentially refers to someone or something capable of achieving outcomes independently. So that's the key too, is something independent. It's like an agent. Basically, it can, it's essentially agentic in AI sense, is that it's used with a type of AI. So that's AI agent that can execute complex tasks autonomously too, with also like a little bit of human in the loop involvement too. But of course, in today's time, there are lots of agents that actually still needs a human in the loop type of interface. Now, let's then quickly then talk about Gen AI agents. So these Gen AI agents will be there to help orchestrate these complex workflows too. And it coordinate the activities of multiple agents, and it process logic as well as evaluate answers too. Now, multi-agentic systems. So now we live in a complex world in a lot of cases in which we have multiple agents doing different things. And I'll show you an example in a few slides more. But basically, too, we want these agents to all work together autonomously. And each of them specializes in different tasks. And emerging intelligence from agent interactions, too. So some agents will help to actually divide complex tasks into like manageable subtasks, and it leverage strengths of different AI models, and it increase robustness and fault tolerance too. Now, this is just kind of a quick thing about in Java. If you're a Java developer, basically LangChain 4j uses this approach of an AI services. This one will act as give you the declarative interface to the desired API underneath via an object or in proxy too. And then I wanted to also point out there's this model context protocol. As such, you may ask, well, what does it have to do with event system? But of course, too, if, you can be writing maybe certain agents and conforming to the model context protocol, which is actually came out of Anthropic, as you know. It is an open protocol that standardizes how applications provide context to the LLMs. So you can also kind of take a look at this and see if when you develop MCP compliant agents that are provide a service as a server or as an agent as a client as well, that you can also make sure you are conforming to these standards. So it makes it easier if you're going to be changing maybe interaction with different LLMs, but you follow the pattern. It will be much easier than if you write your own way how you interface with it too. Now, let me also then really quickly talk about EDA, event-driven architecture and multi-agent for Gen AI. So you can see too, there are key components of event bus that manage event streams. There are also like API gateway that handles external events. Agents can be autonomous components with specific capabilities, and then they each kind of work with different types of models accordingly. So these are the underlying generative models too, depending on the needs, right? You can be image, again, can be image or text or, audio or video, so on and so forth too. And there are also different event types and agent types too, as you can see. For agent, we need coordinator that will decompose this task and assigns to agents, generator, evaluator, refiner as well. And types too, you can have different event types that gets generated too, basically. Assigning a task, a result generated, user request, final responses. These are just a small handful of the types of events that you can be defining for your system too. Now, this particular case I wanted to share is also on archive.org. The archive paper is based on Microsoft AutoGen system too. But as you can see, there are lots of interaction, the conversations in between. So we can be using an event-driven approach to be kind of supporting this kind of multi-agent conversations that go back and forth. And there's also the need for human in the loop type of interaction. So we can also be considering that. Agentic design patterns. Now, this I won't go into way too much kind of detail at this point, but want to point out there's reflection, tool use, planning, and multi-agent collaboration that we can actually, on each level types of the patterns, we can be applying event-driven type of approach to it too. So if you kind of take a look through this, I have some kind of explanation of each one of them, but in the interest of time, I won't kind of get into a lot of the details here, but here too, this is the one I wanted to show you as an example, coming out of deeplearning.ai. It is also on archive.org too. So I give you the link here. You can take a look at it. But basically, as you can see, this is a multi-agentic collaboration example in which we're mimicking an IT project. So you have, it's like just like any other projects, you have people doing coding, doing designing the UI, testing, documenting. So in this particular case, if we need to implement as an agent, then we can be essentially having the different agents be responsible for different tasks. And then you also need a project manager that will be orchestrating, making sure everybody's doing their task and put them all together and directing how things should be going, the orchestrator overseeing it. Okay, so these are just a few examples of multi-agentic libraries here. AutoGen for Microsoft Crew AI, and LangGraph is the graph kind of approach from LangChain 4J, and then also, not 4J, just the LangChain, and then also for Java side, there's Quarkus and LangChain 4J integration that's based on CDI, as well as Spring AI, which I didn't specify in here, but I thought I should mention too. I provide you with some examples from Crew AI. They may not be actually be using really event-driven, but we can think of situations, scenarios in which we can actually be applying the event-driven approach to implementing it. Do not forget there are also challenges too with Gen AI. Complex, right? These are, if we're doing event-driven, is complex system design and coordination, the same type of thing that we do even in non-AI situation. We need to be able to ensure consistency across like distributed agents, handling failures and partial results. In other words, we need to build very good observability support to it, and also optimize for latency and resource usage, sustainability issues, hallucinations, ethical concerns, potential misuse, and also prompt injection. So with that, I want to thank you and want to share with you some resources. This is the QR code and bit.ly link to this slide deck. If you miss it, the organizers will also have it. And from here, you can find a lot of links too. For example, these are things that I've shared in here. I want to point out my article on Java Advent Calendar from December 2024. I wrote about event-driven approach. I have some example code in there too. And then also my stream on Twitch and YouTube. I'd like to invite you to follow me. I'm trying to get back to it now after my busy travel schedule. And with that, I want to thank you. I'm also, again, I'm leading Chicago Java Users Group, all of these things, and my Discord server too, if you like to stay in touch and have more conversations. And with that, I want to thank you very much again to Stream Native, to the organizers, and wanted to wish you all very successful implementation of event-driven systems for Gen AI purpose.
All right. Thanks, Mary. That was very enlightening. Thank you so much for sharing your experience and insights.
Thank you so much.
Yeah.
Thank you for those of you who are attending. Yeah, thank you.
Yeah. Okay. Fantastic. All right. So now Mary is ready to take live questions if you guys have any for her. I know we have two from the chat in case people have not seen that. I can read out the questions and then Mary, if you don't mind, we can address them live again.
Sure.
Okay, perfect. All right, so we have the first question. Do we have any sort of grammar on what the different LLM can do or have limits around? Some can do only text, some only do images, some can do both. Not all image generation is the same. Some can even do animation. It seems to me that it's going to be incredibly important given that there are not all the same. So, right?
Yeah, sure. So I'm just repeating. I think thank you first of all, Peter, for asking. That's a great question. It is very true that their LLMs are, they are not all created the same, as we know, and some are, primarily to modality is essentially indicating the data types that it can support. And as we know, all know, maybe most of you know, is that there are six major types: the text, image, audio, video, code, and also three-dimensional data. So essentially, too, nowadays, I think the models are, most of them are getting more sophisticated, like Gemini, O1, from OpenAI. These are multimodal. But otherwise, too, for example, like Codex, right, for GitHub Copilot, they are code specific, or like audio, such as Whisper or Sora from OpenAI. And these are, Sora is more video. So as such, too, yeah, there are different modality of these LLMs. So yeah, and Peter also asked another question too, right? Yeah,
Yep.
maybe next
Go
question
right
I'll
ahead.
let you read too. So yeah.
Oh, okay. Thanks. All right. So the next part follow up is so basically they're thinking that there could be a way to integrate an LM when you first uh, hook up to it, an automated way to say, okay, what are you and what are you capable of? Like some sort of client server handshake so that the client doesn't ask things of the LLM that it's just not capable of answering.
Yeah, another good question. Yes, Peter. In fact, we can just ask to whenever, through the prompts, we can basically ask LLM, what are you good at? And it's supposed to tell you what it is supposed to be for. Obviously, yeah, nothing kind of, prevent us from directly asking. But I do want to point out, interestingly, too, I mean, as such, right? That might be a question that I'm sure most LLM can answer. What are you good at? Or what kind of modality you support? And it will tell you. But interestingly, too, for LLMs, as I'm kind of getting to know a bit more about it, I'm less of kind of the training models, but knowing how it is, the smaller size models as such, has a lot more hallucinations and it's like for good reason too, because they are smaller, they just cannot handle a lot of things. And if you want accuracy, you want to use the ones that are as big as possible. So in general, they can answer you properly or at least tell you kind of like what it doesn't know and what it knows. But I wanted to point out, interestingly, too, is I did a workshop in Sweden for a JFocus conference, a workshop, and then one participant downloaded the DeepSeek, the 1.5B, because like for the I wanted to use Olama, right, to run it locally. So he tried that. And then immediately, too, he asked a question to this small DeepSeek, and it says, how can I commit a crime? And interestingly, the DeepSeek, that small little model, come back and said, sure, let me teach you how you can commit a crime legally. It was kind of just really funny, too. So as we all know, right, I'm just kind of sharing with you because that reminded me that a small model can be very unpredictable and very funny too. But just don't take it too seriously. So, but they are good for doing like smaller tasks, right? That you can, let's say, our systems normally cannot handle the really big ones. So if you want to just test things out, use the smaller models. That's fine too, but not for serious stuff. So yeah, yeah,
Awesome. That's very interesting. I wish I was there to see how DeepSeek teach me commit
yeah,
crime legally.
yeah. Right.
Okay, perfect. Okay, so Peter basically answers to close this one up. So Peter saying, okay, that's my issue. The smaller models will straight up lie to you about what they can do. That's why I was thinking for some sort of objective stigmata grammar that it cannot lie about. It has to hand over its credentials when asked.
Mm, that's right. Yeah, Peter. So, exactly. Yeah, the smaller models is not very trustworthy at all. But again, I think they have their use, for more testing type of purposes. But you're thinking of having some sort of objective schemata and grammar, right? That it can't lie about, which is, I think it's also a good idea to somehow, right, to kind of warn people if, it happens to be a small model answering the question, it's probably, yeah, should be. I think that's a good idea about it too. And also, you said in Hanover is credentials when asked. Yeah, Yeah, you can also kind of do so too. But I think sometimes when we're using some model, we probably ought to be aware of the, the limitations, so to speak, right, of each of the model that we're working with. And that's a very good point, Peter. So
Perfect. I think we have less than 1 minute left, and we may just get cut off any minute now. So I'm
sure,
just going to read out the first question very fast and then see where we're at.
David. Yeah.
How do you envision EDA and agentic AI working together? Have you seen any interesting patterns or frameworks that have resonated with you?
Yeah, great question, David, and thank you. It's good seeing you here. Yes, I think to me, right, I think there are lots of potential in EDA and agentic AI, but I think at the same time, I don't find a lot of actual thing to that actually talk about it. I'm hoping to see more. Maybe, David, I should reach out to you. I know you're very amazing too. So I would love to have more conversation with you and anyone too. I would love to do more research in this area and actually build out some samples to test out more event-driven and helping out with multi-agentic type of calls in for LLM. So I think there's a limited potential is what I look at it. So yeah.
Agreed, agreed. Awesome. Well, perfect timing. Thanks so much, Mary, for joining and giving us your insights, sharing experience. It's very enlightening. And we'll keep in touch. Yeah. And then
Great.
thanks everyone joining. We'll see you guys in the next sessions.
Yeah.
Yeah.
Enjoy. Yeah. Thank you.
Thank you.
Okay.
Bye.
Thank you. Bye bye. Okay. Great.